So when you're solving log equations, a couple different strategies. We always try, when you solve a log equation, change the logarithm into exponential form. So when I say exponential form, when you have a log expression, so log base a of x is equal to b, remember you can change, as long as you have a log equal to a constant, you can flip a log equation into an exponential equation by taking the base of the logarithm, raising it to b, and that would be equal to x. So the big strategy when you're solving log equations, if you can get it set up so that you have a single log on the one side equal to a constant, to flip it into an exponential equation, try solving it that way. However, before you can do this, you may have to do some manipulation using your properties of logarithms to condense. So we want to smush, I call it smushing. So when you're trying to solve a log equation, you want to do all those properties, all that condensing first, to then see which strategy you're going to have to solve the log equation. Again, whenever possible, we're going to find the exact solution by solving for x. So we're going to leave things in exact form. There are some log equations that you have to use your calculator for, and that's when we'll get an approximate answer by using the calculator. The big thing you have to remember about your solutions when you're done solving log equations, you've got to look at the domain of each part of the equation and check your answers to see if any of them are extraneous. Hear that sign. Remember, from last year, there are lots of different types of equations you looked at where you ended up with extraneous solutions. The reason why you're on the lookout for extraneous solutions is if you remember what the domain of a log function is. So if you've got the domain of log of x, the domain of all your log functions is that your x values have to be greater than 0. So what you have to do is you have to check your solutions back into the original equation. And I'm capitalizing original. You always go back to the original, not the one you smushed. Go back to your original equations. You need to reject any answers that give you the log of a negative number. You cannot do the log of a negative. Those are your extraneous solutions. Just because you have a negative number doesn't mean it's extraneous, because depending upon the operations that are happening inside the log, it may work. So you always plug them back into the original. All right? So one strategy we use to solving log equations, like I mentioned, is try to flip it into a form of a log equals a number, and then flip it into exponential. Another strategy would be to not only flip it into an exponential, but if you can get a log of something equal to the log of something else. One of the properties we talked about the other day, if you have a log equal to a log, then it has to be true whatever's inside the log functions also have to be equal. So these are really the two strategies you try to work with when you're trying to solve a log equation. Either log equal a log, or you try to flip it into an exponential. Okay? So those are the strategies we look at when we're solving a log equation. All right, so let's take a look at 2a. 2 log base 5 of x is equal to log base 5 of 9. First of all, use any properties you can. What log property can we do in 2a? You can move this 2 to what? We can move this 2 to become the what? Exponent. So log base 5 of x squared is equal to log base 5 of 9. Now, this is where we have that strategy I just mentioned. You have a log equal to another log. What has to be true about these two? They have to also be what? Equal. So I can take x squared and set it equal to 9. So what's x going to be equal to? Positive and negative 3. But now what do you have to do? You have to check your answers. Remember, you don't go back into the smushed one. You go back into the original. If you plug in a positive 3, I'm good. Well, can I keep that negative 3 as one of my answers? No. So I have to reject the negative 3. So my only solution then is going to be x equals 3. So you have to reject that negative. Okay, remember, you cannot take the log of a negative number. It's out of the domain, remember. That's the reason. Because the domain of log functions have to be greater than 0. not do the log of a negative. So you got to check those answers. Let's take a look at B. So we have the log of 3x plus 7 plus log of x minus 2 equals 1. Like I said, always swoosh. Use any properties of logs that you can before you start solving. How can you condense the left-hand side of this equation? Use what property? Use your quotient property. We can bring it together through what? Bring it together through multiplication. So now you have a log equal to a number. So you can use that other strategy I mentioned. By the way, what is the base of this logarithm, even though it's not written? 10. Remember, it's the base 10 is our common logarithm. So I can now flip this into exponential form. 10 to the first is equal to 3x plus 7 times x minus 2. Now you don't have a log equation anymore to solve. You just have a straight algebraic equation. How would you solve this particular equation? No, I'm just not going to take 3x plus 7, set it equal to 0, and x minus 2 equal to 0. This equation's not equal to 0 yet. So what are you going to have to do on the right-hand side? We're going to have to what? We're going to have to what? Boil it. So 3x times x is a 3x squared. Outer term is a minus 6x, inner term is a 7x, that's going to be an x. And then my outer term is going to be a minus 14. Now that I've distributed, I've gotten rid of the parentheses on the right-hand side. Now what can I do with that 10? I can do what? Subtract it. So 0 is going to be equal to 3x squared plus x minus 24. How would you solve that? Slide and divide, you need to factor it. So go ahead and factor that for me. You end up with the x plus 3 times the 3x minus 8. So now what are your solutions going to be? X is equal to what? X is equal to negative 3 and 8/3. Now what do you have to do with those answers? You have to plug them back where? Plug them back into the original. So go back to your original. If I plug in negative 3, well, negative 3 times 3 is a negative 9. Negative 9 plus 7 is a negative 2. No need to even check it in the other one, because what happens? I end up with a log of a negative. So I have to reject it. So if I plug in 8/3, 3 times 8/3 plus 7 is good. And then 8/3 minus 2 is good. So I know that 8/3 is going to be my only solution. So like I said, sometimes you'll get 2 solutions. One will work, one won't. Sometimes both will work. You got to check them both though. All right? Any questions on B? Let's take a look at letter C. Can I go ahead and start smushing together those 2 blocks? No, you got a big problem right now, don't you? You've got a base of 2, and you've got a base of 4. So this is where I mentioned to you the other day that the change of base formula is used not just for calculator purposes. We use it to solve log equations when you have an equation with 2 logarithms with different bases. So you're going to have to, no matter what you do to get started here, you've got to do a change of base first. You can't do anything with this equation unless all the logarithms have the same base. You can go into base 2 or base 4, it really doesn't matter. My recommendation is change everything into the smaller base. All right? That way you avoid fractions. You can still work it, but that way you avoid fractions. So I'm going to change log base 4 into a base of 2. So remember your change of base formula, log base 2 of 3x plus 2 minus. To change this into a base of 2, it'll be log base 2 of x divided by log base 2 of 4 is equal to 3. That's your change of base formula. Now, if you take a look at this denominator, don't panic because you see this log base 2 of 4 in the denominator. Take a look at this log base 2 of 4. Evaluate your logarithms if you can. Yes, please. Yes. So remember, this is asking you the question 2, the base, to what power is equal to 4. That's what log base 2 of 4 means. 2 to what power equals 4? And as Jason just said, 2 to what power does equal 4? 2. So you can simplify this log base 2 of 4. So log base 2 of 3x plus 2 minus log base 2 of x all over 2 is equal to 3. Now, just like any equation, we always try and clear all fractions out of the equation. So what can I multiply this entire equation by? 2. So I have 2 log base 2 of 3x plus 2 minus log base 2 of x is equal to 6. Now do you see some smushing? Now I have all my bases of 2. Now I got rid of that ugly fraction. Now do you see the property of logarithms that I can do to start doing my smushing? On the left-hand side, I can move this power and bring it together through division. So I can rewrite the left-hand side as log base 2 of 3x plus 2 squared over log base 2 of x, equals 6. So I move my power, and then I use my quotient property. Now what? Any thoughts on what we're going to do next? Change it into what form? Change it into an exponential. Because remember, I have log equal to a number. So 2 to the 6 is equal to 3x plus 2 squared all over x. At least now I've gotten rid of the logs. So now I'm back to a regular straight algebraic equation. Any thoughts on what we're going to do here? So I'll 2 to the 6, but then again, 2 to the 6 is actually a fraction over 1, so what can you do with it? You can do what? Cross multiply. So 2 to the 6 is 64. So 64x is equal to 3x plus 2 squared. I can now FOIL the right-hand side. So 64x is equal to 9x squared plus 12x plus 4. Thoughts next? What do you have to have on one side of this quadratic equation? We have to have a what? 0. So 0 is equal to 9x squared minus 52x plus 4. Can you factor that? Please say yes. This problem just gets better and better, doesn't it? Maybe. What happens if you can't factor it? Quadratic formula. Quadratic. This problem just gets better and better, doesn't it? This is like the perfect storm. Change of base, and then you got to do all this other algebra, and now I got to do quadratic formula on top of it. This problem's a good one. It's a doozy. So let's review our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that lovely looking thing? How many of you guys sing the song? That's, yeah, the song. I think it goes to Pop Goes the Weasel. Oh, you don't want me singing it. You don't want me singing that song. That would be a scary thing. So, yeah, let's just review. With this quadratic, what is A equal to? A is equal to what? 9. B is equal to what? Negative 52. And then C is going to be equal to 4. So x equals negative 52, that's going to be positive 52, plus or minus the square root. 52 squared minus 4 times 9 times 4, all over 2 times 9. Obviously, if you do not have a calculator, we do not certainly give you a number as 52 squared to do by hand. 52 squared is 2,704. So 2,704, I'm just going to go ahead and finish with another radical. Minus 4 times 9 times 4. 2,560. All over 18. $256 is a perfect square staring you in the face. Square root of 256 is 16. So I can reduce this now. Sorry, I'm going to go a little bit. 52 plus or minus 16 times square root of 10 all over 2. Isn't that a beautiful number? Yes, you can, because what can you divide out of everything? It gets better, doesn't it? 2. So finally, hopefully I'm getting somewhere. So finally, where the heck did I start? So finally, 26 plus or minus 4 square root 10 all over 9. But what do you have to do now with your answers? Check them. Where do you check them? Gosh, where the heck do I take this? I check it back to be what? Original. The big question is, I know 26 plus 4 square root 10 over 9 is positive. Oh yeah, 16 divided by 2 is 8 last time I checked, thank you. The big question is 16 minus 8 square root 10. Is that going to be a negative number or a positive number? So if you want to check 26 minus 8 square root 10, it is a positive number. So they're both going to work. All right, they're both going to work. All right, so both of those will be your solutions. So they're both positive. Okay? I don't think I can give you any worse of a problem on tests like that. Obviously, if I made you do change of base, I won't be that mean and make you have to do quadratic formula and all that. You may have to use quadratic formula. But again, it wouldn't be on this dance scheme a problem. I mean, you'll definitely be able to change the base, but you'll get down to one you can factor at least. It's not that ugly. Okay? Any questions on that? All right, let's take a look at D. Wow, hopefully this one's a little bit better. Well, first of all, can you condense on the left? Yes, so let's do the condensing first. So natural log of x squared over 3 is equal to 2. What's the base of this logarithm? E. So now I have log equal to a number. So what can I do with this equation? I can flip it into what? E squared equals x squared over 3. Remember, E is just a number. You're solving for x. So how am I going to solve for x? Multiply by what first? Multiply by 3. So 3e squared is equal to x squared. Now how would you solve for x? Square root. So x is equal to plus or minus. Now can you reduce the square root of 3e squared? Yes, because what's the square root of e squared? E. So plus or minus e times the square root of 3. And again, check it back into the original. Do I have to worry about having any negatives? Because you're squaring x, so this negative e square root 3 is just going to become positive. Okay. Oh, we're not going to have a calculator for problems like this. So. All right, are we good on D? Okay, so let's now take a look at some exponential equations. Now, exponential equations, remember, have the variable in the exponent. So one way to solve exponential equations is you try and rewrite both sides of the equation with the same base. So one strategy when you are solving exponential equations is if your bases are the same. So if you can get your bases to be the same, for example, in this case 2, if the bases are the same, it has to be true that the exponents can be set equal to one another. So one goal when you're solving exponential equations, if you can, try and get the bases equal to one another. A lot of times you can't do that though. So if that can't happen, we're going to need to use properties of logarithms along with algebra to find the solution. So one strategy is to get one base equal to another base, or you will end up taking the log of both sides of the equation. So you end up taking the log of both sides. Remember, you're solving for an exponent. So let's take a look at 4a. 1,000 e to the negative 4x is equal to 75. So first of all, you want to always isolate the base that has the variable. So what's going to be my first step? Divide by 1,000. So I have e to the negative 4x is equal to, now reduce 75 over 1,000. Yeah, I can take out 25, that's going to give me 3 over 40. So I know I cannot change 3 over 40 into a base of e. So what I need to do then is now I'm going to have to somehow, some way, get that negative 4x out of the exponent. So this is where you can take the log of any base. It can be log base e, log base 10, log base 5, it doesn't matter. But we need to take the log of both sides of this equation. Most commonly we use the natural log. So the natural log of e to the negative 4x is equal to the natural log of 3 over 40. Keep that 3 over 40 inside parentheses. Now that you've got the natural log of e to the negative 4x, you can use your power property of logs. We can take that negative 4x and get it out of the exponent. So I have negative 4x times the natural log of e is equal to the natural log of 3 over 40. And what is the natural log of e equal to? The natural log of e is equal to what? 1. So I have negative 4x is equal to the natural log of 3 over 40. Now how do you solve for x? You're going to do what? Divide by negative 4. The thing you have to be really careful about with the answers when you're checking, there's a lot of different equivalent answers that you could write that are absolutely correct. And in fact, a more common answer you're going to see is negative 1/4 times the natural log of 3 over 40. So instead of seeing that natural log divided by negative 4, you're going to see that constant coefficient. Even more commonly, when you end up with a logarithm that has a negative in front of it, using your power property, this is equivalent to 1/4 times the natural log of 40 over 3. How are these two equivalent? They just are. It's magic. Because what's the negative? This is actually a negative exponent, correct? So what happens with the negative exponent? You take the reciprocal. So remember, there's just 3 different ways I wrote this correct answer. More than common, when you're dealing with a negative ln, a lot of times they will remove the negative, use that power property, reciprocate what's on the inside versus leaving a negative in the front. You just have to be able to recognize your answer could be written several different ways. Yes, Jason? Yeah, but usually with an answer you want to condense as much as possible. But you're absolutely right, that is not an incorrect answer. Okay? But usually with an answer you condense as much. Any other questions on that one? So now let's take a look at B. Back earlier in the year, I introduced to you the idea that quadratic equations can come in many forms. And we studied the trig quadratic equations. You're used to seeing just an x squared. But what makes a quadratic equation is when you have a base raised to a power of 2. When you have a quadratic exponential function, and that's what we have here, this is what you need to be on the lookout for. When you see that 2x as an exponent, it's just a quadratic equation. The base that's being raised to the second power is your e to the x. This is actually e to the x squared plus 6e to the x minus 7 is equal to 0. So be on the lookout. When you see that 2x as an exponent, it is a quadratic equation, and the base is one of your exponential functions. In this case, it's your e to the x that's being squared. If you do not like seeing this e to the x in the equation, you have no idea what algebra to do a dummy substitution. Take it out. Let's just let a be equal to e to the x. If you have no idea what to do, take e to the x out of the entire equation and rewrite it as an a squared plus 6a minus 7 equals 0. We should all be very comfortable doing what with this? What can you do with this? Factor. You can factor. What are the factors of negative 7 that add together give you 6? A plus 7 times a minus 1 is equal to 0. Then what do you do? You solve. You set each factor equal to 0. So a plus 7 is equal to 0. A minus 1 equals 0. So a is equal to negative 7. A is equal to 1. Now, what did we say a was equal to? A was equal to what? E to the x. So e to the x equals negative 7. E to the x is equal to 1. So how am I going to solve this e to the x to the negative 7? You're going to have to take the what? Natural log. Are you going to have a problem? What's your problem? Can't be negative, so there's no solution to that factor. So I'll take the natural log of e to the x is equal to the natural log of 1. So again, x times natural log of e, what is the natural log of 1 equal to? 0. So x is equal to 0. So the big thing is, guys, you got to zero in. When you see that 2x as an exponent, it is a quadratic equation. All right, you're dealing with a squared e to the x, or whatever exponential function squared. All right, so just be on the lookout when you see that 2x is a quadratic. Okay, so you can always do a dummy substitution if that helps. Figure out what the base is being squared into a dummy substitution. That helps. All right, take out your calculators for a minute. Let's jump over and let's take a look at the bottom of page 13 here. Just like every other equation that you've used to solve on your calculator, you can use your calculators to solve log equations in a very similar manner. Again, remember, if you have a TI-83, depending upon the version of the calculator that you have, if you have an 83, you're going to have to use change of base in order to type in log base 2 of x minus 1. So you have to actually rewrite this as the natural log of x minus 1 over the natural log of 2 minus natural log of x plus 2 over the natural log of 6. Again, you only have to do that if you do not have the updated operating system on the calculator, so you've got the 83. So now all you need to do to solve this equation using your calculator, remember, we're going to use the intersection feature. Take whatever's on the left, we're going to type that in under y1. Take what's on the right, type it in under y2. And then find out where those two graphs intersect. So when you go to your y equals screen, if you've got the updated operating system, remember you can find your log button under alpha window. And alpha window, you'll see option 5, log base. That gives you the option to type in any base that you want. So log base 2 of x minus 1 minus, go back to your alpha window again, option 5, log base 6 of x plus 2. So that's under y1. y2, I'm going to type in the 2. And I need to graph it. Remember, we need to see where the two graphs are intersecting. So you may have to adjust your window. So if you need to go to your window and adjust your x max. So you may need to change your x max, I change it to 20. But you have to see that point of intersection. So to find the intersection point, remember you go under second trace, option 5, intersect. And then hit enter 3 times. So we end up with x to be equal to about 12.148. Again, take it to 3 decimal places. So any questions on that one? You guys go ahead and try B on your own.